How will you define electrolysis?
The breaking down of a compound through the passage of electricity.
Very good. So you picked up very fast. But if you're going to be very precise and if you're going to give the detail that examiner is asking, okay. So how will you define electrolysis? When electric current is passed through, okay, a molten ionic compound or aqueous ionic compound. So I repeat, when electric current is passed through, you know what is the meaning of molten, is it not?
Yeah.
Yes? Yeah. So aqueous also, you know, it is a liquid form of an ionic compound. What is an ionic compound?
When it has gained or lost electrons to form a
compound. Very good. Yeah, very good. So a compound that is formed by donating and accepting electrons. That is called as an ionic compound or an electrovalent compound. Can you give me an example for this?
A Pb2 plus ion.
Okay, we can have a simple example, that is sodium chloride.
Sodium chloride.
Is it not? What is sodium chloride? Have you seen sodium chloride?
Yes, table salt.
Very good. So this is an ionic compound. So this is formed by a combination of two elements, that is sodium and chlorine. Sodium donates electron and chlorine accepts electron. So thus this electrovalent compound or the ionic compound is formed. Now what is the atomic number for sodium? What is the atomic number for sodium? It is 11. Okay. So it is 2. The configuration is 281. So the number of electrons in the outermost shell is 1. Okay. And for chlorine, it is 17. The atomic number is 17. So it is 2, 8, 8 and 2, 8 and 7. 7 electrons in the outermost shell. Okay. 7 electrons in the outermost shell. So now to attain a stable configuration, or a stable configuration means it becomes a very stable ionic compound. So sodium donates this one electron and chlorine accepts this electron to form the stable compound, that is sodium chloride. So electrovalent compounds or ionic compounds are formed by the donation or acceptance of electrons. So these electrovalent compounds or the ionic compounds in the molten state or in the aqueous state, when electric current is passed through it to break down the compound, it is called as electrolysis. Okay, got it? So, what is electrolysis? Electrolysis is when electric current is passed through a molten or aqueous solution of an ionic compound to break down that compound to form different elements. It is called as electrolysis. Okay. So the simple meaning with the name electrolysis means electro is electric current, lysis is to break. So electric current is used to break this compound to form different compounds. That is the definition for electrolysis. Now can you tell me what is the definition for electrolysis?
Okay, so it is the breakdown of a molten or aqueous solution of an ionic compound by breaking down the compounds into elements through electricity.
Very good. So when electricity is used, okay, as the media to break down the compound, it is called as electrolysis. Now I use two words, molten and aqueous. You understood what are those terms. Molten state is in a kind of a, what kind of state is molten state? You can see it in the lava and all that, where it is, the temperature is very high. Aqueous means when it is dissolved in water, it forms the aqueous solution. So when sodium chloride is dissolved in water, excess sodium chloride is dissolved in water, what is the name of that solution? What is it called? It is called brine. Okay. It is called brine. B-R-I-N-E.
Yeah.
Okay. Now, sodium chloride, when you see it in the kitchen or in the shop, or it is in what state it is?
Solid.
State. But here I've told, if the ionic compound is in the molten state or in the aqueous state, when electricity is passed through it, the compound gets broken. Okay. Now, why I cannot use the sodium chloride in the solid state?
Because it has...
Take sodium chloride and pass electricity through it.
Is it because it has no free ions?
Correct. So, in solids, if you see, the arrangement is very close. That is positive, negative, positive, negative. So, the particles are closely packed with each other and there is no movement of ions taking place. Whereas, if you see the aqueous state or in the molten state, then what will happen? The negative will be here, positive will be here. So there is movement of ions taking place. So ions is nothing but a particle which carries charge. Is it not? So movement of ions is there, and that is why electricity is able to pass through it and the process of electrolysis can take place. So in the solid state, it cannot take place because there is no free movement of ions. Whereas in the liquid state, that is in the aqueous state or in the molten state, it is able to conduct electricity because there is movement of ions. Is it clear?
Yes.
Because this is one of the important questions which will be asked, which might be asked. Why in solid state, sodium chloride is not able to be broken down even when electricity is passed through? This is the reason.
Yes.
Understood?
Yeah.
Okay. Now we'll see some of the terms. Now, what is the contrast for ionic compound? You say ionic compound is one type of compound that is formed by the donation and acceptance of electrons. What is the contrasting on other one, the opposite of ionic compound?
There's covalent compounds.
Very good. What is covalent bond? How are compounds formed by covalent bonding?
The sharing of electrons.
Very good. And the shared electrons belongs to both the elements that take part in the bonding. Is it not? So covalent bonds are generally not very strong when compared to electrovalent or the ionic compounds. That is why covalent bonds do not conduct electricity or cannot be broken down by the process of electrolysis. Can you give me an example of a covalent compound?
H2O.
Okay.
Yes.
Carbon dioxide, carbon tetrachloride, ammonia. Just because ionic compounds carry charge, they are able to conduct electricity. Okay. So next we'll see another important term. What is an electrode?
It's made of an inert metal.
Only inert metal?
Yes, usually.
Okay. For an electrode?
There's usually a negative and positive.
Yes, so there are negative electrodes, positive electrodes, yes.
So the positive is the cathode, the negative is the anode. And then they attract the ions of the opposite charge, so...
They attract each other, is it not?
Yeah.
So suppose if you are asked to define electrode, so you can say it is a rod of metal, okay? Or graphite. What is graphite?
It's
metal, you know what is metal.
Allotrope.
Okay. Very good.
Yeah.
It is an allotrope of
carbon.
So what are allotropes? What are allotropes?
Is it just carbon with a different structural form?
Yes. So allotropes of carbon are in different forms. It can be in the crystalline form, it can be in the amorphous form, it can be in the fullerene model. So it can be in different forms which will have a different physical structure, but the chemical property will be the same. That is called as the allotrope. That is the definition for allotrope. And what is the general common chemical characteristic of the allotropes of carbon? When they are burnt, they give carbon dioxide.
Yeah.
Okay, that is about graphite. Okay, so which can, so this electrode is which can bear electricity that is passed through the electrolyte. That is, it can conduct the electricity that is passed through it into an electrolyte and outside an electrolyte. Now, what is an electrolyte? Got this point so far? Am I clear to you?
Yes. The electrolyte is the solution. It's the metal is dissolved in.
So that's what is brine. Brine is an example of an electrolyte. So electrolyte is the ionic compound in the molten state or in the aqueous state. Okay, that conducts electricity. Okay.
Yeah.
Now, what is an anode?
Here, the anode is the positive electrode.
Anion is a
negative ion.
Same way, cathode is a
negative electrode.
And cation is a okay. So that's you're thorough with that. Now, shall we see how we can basically set up an electrolytic cell?
Yes.
Do you know that? Can you access the whiteboard as well?
Yes, I can. Yeah.
You can?
Yes.
Then just try drawing an electrolytic cell.
Okay.
Good.
I think this is connected here. Yeah.
So now you've drawn two signals here. Is it not? One big and one small. So what is the big one and what is the small one?
The big one is positive and the small one is negative.
Very good. Very good.
So
right.
Here the positive ions. No, wait. The negative.
What electrode is this? What electrode is this?
Should I draw it of NaCl?
No, you can just write. It's nothing wrong.
Oh, okay.
So you can write here it is an aqueous solution of NaCl. That is the here you have the cathode. Here you have the anode. Okay.
Yeah.
Then you are passing the electric current. So this is the electrolyte solution, that is the brine. And what will be connected here at the cathode?
Would that be the positive?
Cathode is a negative electrode, is it not? So what will attract negative?
Positive.
So hydrogen. Hydrogen behaves like a positive ion, is it not? Like a metal. That is why it is placed even in the periodic table. It is placed in along with the metals. Is it not?
Yes.
Metals, they collect in the which electrode?
Cathode.
Hydrogen is a positive ion, is it not?
Yeah.
Metals are positive. So they should be collected at the negative electrode. Which is the negative electrode?
The cathode.
The cathode is a negative electrode and cation is the positive ion. So the negative ions, like for example chlorine, bromine, okay, sulfur, nitrogen, all those are
attracted
anode. So they should be attracted to the positive electrode, is it not? What is the positive electrode?
The anode.
Okay. So got this? The difference between anode and cathode, difference between anion and cation.
Yeah.
You should not get confused because an anode is different from anion as far as the charge is concerned.
Yeah.
Is it not? And cathode is different from cation as far as the charge is concerned. Got it?
Yes.
So far is it clear for you?
Yeah.
Okay. So now you've seen what is electrolysis. You've seen the definition for what is an electrode, what is a cathode, what is an anode, what is an anion, what is a cation, what is an electrolyte. Is it not? Now what is electroplating? Can you tell me an example?
So is it the separation of the metallic compounds? It's to cover an object. Is it to cover an object with your desired metal?
Yes. For example, these iron rods, when they are exposed to moisture, they get a coating of brown coating on them. That is called rusting. Yeah. So to prevent rusting, we either paint or do this electroplating, which means coating with a layer of zinc. Is it not? To prevent this rusting, and that is called galvanization. It is called as galvanization. Is it not? That is called as electroplating. So how will you define electroplating? When a metal is coated with another metal on top of it to prevent any chemical process happening. Here it is rusting. So chemical process happening, then that is called as electroplating. Clear?
Clear.
Okay. Now what is an inert electrode? With the difference to this chapter, it is inert electrode. But then we have seen inert gases, we have seen inert metals and all that. Is it not? So what do you generally mean by the term inert?
Unreactive. So it has a full outer shell.
Yes. So they don't react. They are placed, the metals, inert metals are placed towards the last in the reactivity series. Is it not? So generally they are also called as noble metals or noble gases. Is it not? Why noble? Because they don't react. That is why they are called as noble. So here inert means they are unreactive, and these inert electrodes, example is platinum. Is it not? So these used in the electrolysis process. These inert electrodes are used in the process of electrolysis. Okay. So these definitions you just keep in mind what we have seen so far. First we saw electrolysis, then we saw what is an electrode, then what is a cathode, what is an anode, what is a cation, what is an anion. Then we saw what is electrolyte, what is electroplating, and then we saw inert. What is the meaning of inert? So can you give me some example of an inert gas?
That would be neon, argon,
helium. Those are examples of inert gases. Generally, why they are called as inert gases or inert metals?
They're unreactive.
Yeah, they are unreactive. Why they are unreactive?
Full outer shell.
Yes, they have a complete stable electronic configuration, which means that their outermost shell always has the required number of electrons, that is 8 electrons. Okay, so far it is clear. So we will go to the next. I'm drawing all diagrams here. So we will go to the next topic which we are going to see is the electrolysis of brine. Okay. So I already told you what is brine. Sodium chloride. So I already told you the aqueous form of sodium chloride is called
brine.
Brine, B-R-I-N-E. And I also told why electrolysis can happen only in the aqueous solution. Is it not? Because movement of ions is there. Whenever there is a movement of charge is there, it can conduct electricity. So here we are going to take in the tank, we are taking the, what solution should be taken now? An electrolyte is taken. What is an electrolyte?
Brine.
Very good. Brine. Here we are having 2 electrodes. So these electrodes are made up of the inert metal platinum, or we can use graphite also. I told you what is graphite and what is platinum. Why it is called as an inert metal. Okay. And here I am going to supply charge. Charge is electricity is passed through. Okay. Now this is the cathode and this is the anode. So always remember, cathode is the what electrode?
Negative.
Negative electrode, and anode is the positive electrode. So when you know that sodium chloride comprises of sodium, chlorine, okay, and hydrogen. All these will be released.
Yeah.
All these will be released. Now, sodium is positive, chlorine is negative, and hydrogen is positive. So, sodium and chlorine being positive will be attracted towards the
cathode.
Very good. And chlorine will be attracted towards the
anode.
Anode, being a negative ion, leaving behind sodium. You know that water also consists of oxygen. So, leaving behind NaOH. Leaving behind NaOH. What is NaOH?
Sodium hydroxide.
Sodium hydroxide. It is a strong alkali, strong base. So, when I say it is a strong base and a strong alkali, is there a difference between base and alkali?
Yes, I think it's not all bases are alkalis.
Yeah, all alkalis are bases, but all bases are not alkalis. So
yes.
Bases which are highly soluble in water, they are called as alkalis. So sodium hydroxide is one of the strong bases or strong alkali because it is dissolvable in water and also it is extremely reactive. Okay. Yeah. Okay, so sodium hydroxide is formed. So the products that are formed here, that is you have sodium hydroxide. So sodium hydroxide is used in the preparation of soaps, okay, and detergents. Because when you see a solid soap, the main content of that solid soap is sodium hydroxide. Okay, hydrogen is used for preparing these margarines, that is hydrogenation of fats to form this E. Okay, chlorine, you know, it is used as bleaching in all your swimming pools, in water tanks, as bleaching agents in your paper industry. So chlorine is used, leaving behind this sodium hydroxide solution. This sodium hydroxide is again used for making this number of products. Your washing soda, baking powder, sodium bicarbonate, plaster of Paris. All this is formed from the sodium hydroxide and the products got because of this electrolysis. Okay, now we are getting two important products in this. One is the alkali, okay, and one is chlorine. And because of this, it is called as chlor-alkali process. Because of this, it is called as chlor-alkali process. Why it is called as chlor-alkali process? Because chlorine is also released and alkali is also produced in this process. That is electrolysis of this aqueous solution of sodium chloride. And from this sodium hydroxide, we are able to manufacture number of products. And that is why this is called as chlor-alkali process. Important. Clear?
Yes.
Any doubts in this? Now, how do you test when bubbles of hydrogen gas is produced? What is the test for hydrogen gas?
The lighted splint produces a squeaky pop.
Correct. When a burning splinter is introduced near the outlet of this cathode, of this electrode, it produces, it is put off with a pop sound. That is a test for hydrogen gas.
Yes.
Chlorine, needless to say, it produces that pungent smell. Is it not?
Yes.
And sodium hydroxide, you know that the base will be very caustic to touch. It is very soapy and bittery. It has this taste on the sodium hydroxide is very important. Now this sodium hydroxide, okay, chlorine that is produced, hydrogen that is produced, all this has number of industrial uses, okay, and also they are used as the main reactant to produce number of products. As I told you, your sodium bicarbonate from which the baking powder is formed. Then you have this plaster of Paris produced, which is very important. Then sodium carbonate, which is washing soda. So all these are produced from this process. Many products which have industrial uses and also common uses are produced.